All right. Bienvenidos. Welcome everyone to our second STEM talk and the last one of the semester. So excited to have you here, whether you're on Zoom or at the watch party. Welcome, welcome. For the in-person one, we do have a sign-in sheet going around for the extra credit if people are doing that. And this is a series that we are going to continue. So keep an eye out for it next year and the years to come. We're going to keep bringing in STEM professionals of various fields to share about their experiences, their journeys, as well as the really interesting things that they've learned and that they're doing now. So I'm excited for today to introduce Dr. Ignacio Barradas, or Nacho Barradas. He studied mathematics at UNAM, where he also earned his master's degree. And then he went on to get his doctorate in biology and mathematics at the University of Heidelberg in Germany. So he now is a senior researcher and the Dean of Graduate Studies at CIMAT, the Centro de Investigación en Matemáticas in Guanajuato, Mexico. So we get to have him coming in from Mexico, zooming in, which I am thrilled about. Someday we'll have him here in Monterey. We're looking forward to that day. But his research interests currently are in the areas between biology and mathematics, especially recently in ecoepidemiology and infectious diseases and their control. That's something that's caught all of our interests. His personal hobbies include reading about any subject and doing magic, especially using mathematics. So without further ado, please give a warm welcome, whether you're in person or a Zoom welcome, to Dr. Ignacio Barradas with the magic of math, or the math of magic.
Thank you very much. I'm really happy to be here. Thank you very much to everyone involved in organizing this meeting and making possible for us to meet. Es un placer estar con ustedes, todos los que hablen español. Les agradezco mucho también estar aquí. The idea of this talk will be to let you with at least one idea. If I succeed, it's because at the end of this talk, you might think math is fun. Math is nice. Math is different from what I thought at the beginning. If I get that, I will be very, very happy. If I get close to that, I'm still happy. Okay, let's start. I'm going to share my screen and I will start sharing some slides. Let's see, magic of math, the math of magic. When I tell people I like magic and I use math, they think these two topics are different from each other. And one of my claims is that they are not really different. So let me start by asking you, what is magic and what's math? What's mathematics? If any of you want to share some ideas, what do you think is mathematics? If someone asks you what's mathematics, because if someone asks you what is biology, the study of life, if someone asks you what is geography, it's the study of the earth. So what is mathematics? I have been asking this to many, many people. And if someone wants to share some ideas, I just stop for a couple of seconds. Is there anybody interested in sharing what this idea might be? There is a chat comment. The language of science, great, good idea. Anybody else?
So someone here said the study of numbers.
The study of numbers. Thank you very much. Any other idea?
Another one here. The language of the universe.
The language of the universe. Wonderful. I could agree with all of them or disagree with all of them. Let me start by disagreeing. It's much nicer to disagree than to agree. Let me change. What does mathematics mean? let's go to the Greek root of this word. Mathema means what there is to know. There is no numbers. Maybe the universe is there, but there is no numbers. By the way, numbers were never part of mathematics. If you look mathematics in Greece, they include music, they include astronomy, they include geometry, but they do not include numbers. That's disappointing for many people. Numbers were so not valued. If you were asked what are the Greek numbers, because the Roman numbers you know, but the Greek numbers, very few people know the Greek numbers. And one of the reasons is people in Greece completely dislike numbers. Numbers and dealing with numbers, they call logistics. You know the word logistics in a different context, and what it means is just dealing with what you have to deal, but something very mechanical, not intellectual. So it's logistic. Numbers are not in mathematics. So what is mathematics? Okay, what there is to know, and there's another wonderful word I love. There is no verb in Spanish, and probably not one in English for the next word, mathein, to think correctly. So the root of the word talks about thinking correctly, and about not numbers, not geometry, not calculus. It is about what there is to know. So my translation, and this is mine, you can use it or dislike it, is to correctly think about what there is to know. That is really interesting because we think mathematics has to be serious, has to be mechanical in some contexts, has to be scientific or at least some symbology. No, mathematics happens every time we think. If we think correctly, even if we don't want to bring our homework today, the way we invent excuses, that's mathematics. We try to find a right excuse, believable. We want people to believe that's true. The dog ate my homework, something like that is not acceptable anymore. So let me start by one example, my personal example, of course. I will stop sharing the presentation and I will go back to my camera and I will show you my desk. I need a nice volunteer, actually 2 nice volunteers to play poker. If anybody would like to help me to play poker, I have cards here. I need 2 volunteers. One volunteer is going to lose, another one is going to win. So nice volunteers, one willing to win and the other one willing to lose. Anybody? Great, thank you very much. Is it possible to open the microphone?
Yes, it is, Doctor.
Wonderful. What do you like to be called?
Well, my name usually works. It's Raymond.
Raymond?
Yes.
Okay, thank you, Raymond.
Of course.
Is there anybody else who wants to help us?
I think we had a volunteer here.
Wonderful.
Yeah, you want to
Okay.
come on down.
Usually I would ask for a round of applause for our candidate. So who wants to win? Okay, Raymond is going to win. He was the one to show his hand first. So our volunteer on the hall is, what's your name?
My name, it's Xavier.
Say it again, please.
Yeah, my name is Xavier or Javier, whichever you prefer.
Oh, Javier is much easier for me. Okay, Javier, I'm very sorry you are going to lose. But it's going to be your fault. So we don't feel that bad. We feel bad for you, but you're going to lose, okay? But the good side is you are going to make all the decisions, okay? this bunch of cards you are going to mix. Usually, let me tell you, I don't need to touch the cards. I'm going to touch the card because you are on the other side of the screen, but I don't need to touch these cards. I could hand this card to Javier and this card to Raymond, and they would shuffle and do all the things. I don't need to touch the cards. I'm going to touch them just because someone has to move them, but there will be no sleight of hand, no trick, no. What you see is what you get. Okay, I put this on this side. Javier, you want to mix these cards, so you just tell me. I can start doing like whatever. I put one in the middle, but it's me. So you want to mix? You could tell first one on the top, put in the middle, or the last one put in the second position. Whatever you want. Which one do you want to mix?
The second from your right.
Yes. What do I do with this one?
Sorry?
What do I do with this card? I move that card to where?
What are we? Move it to all the way to your left.
Okay. What else?
Take the middle card.
Like this one?
Yeah, put it all the way to your right.
Okay.
And take the card second from your right
Okay.
and put it in the middle.
Somewhere in the middle. Is here okay?
Yeah, that's okay.
Good?
Yeah.
Are they shuffled? Are you happy with the position?
Yes, I think I am.
Okay. Remember, you shuffle these cards. Raymond is going to mix these cards. Okay. Shuffle. We want to shuffle them.
Okay, if you would divide the pile into.
Let's do some random movements, and then we can add some additional. Okay.
Actually, I'm content with what you've just done.
Should I undo that?
No. Just as it is, as you've done, and as the cards are right now.
Are they okay?
Yeah.
Okay. Let's ask our victim. Javier, are you happy with the cards Raymond decided to mix, or you want to change any card?
I think I'm okay with it.
You're okay with it. Okay. So these cards are shuffled. These cards are shuffled. Which bunch do you want to put on top?
And to whom are you addressing the question? I'm sorry.
Javier, I'm going to put them together. Which bunch do you want on top?
Put mine on top.
This one on top, like this.
Yeah.
Okay. Remember, you shuffle all the cards. So the decision is yours. So if you lose, what you are going to do, it's your fault. Okay? So that's the position of the starting position. And then I would ask you to deal. You take one card for Raymond, one for you. Okay? Nothing sneaky. 2, 2, 3, 3, 4, 4, 5, 5. Okay? So which card you get is your decision because you shuffle the cards. Do you agree?
Yeah.
Okay, let's see what's your losing hand. Your losing hand is, I don't know if you can see them. I think it's a pair of queens. Yes?
Yeah, I see a pair of queens.
Okay, not bad. Not bad. Okay. Are you happy with your pair of queens?
Yeah.
Do you want to know to which hand do you lose? Because this hand beats yours.
Yeah.
You don't believe me?
Well, I don't really play poker, but
Let's see. What do Raymond need to beat your hand? If you have one pair of queens, he needs two pairs, a higher pair, I mean kings or aces, or two pairs, or three of a kind, but he's not that mean to you. He's a really nice guy, so he's going to beat you with just two pairs. Let's find out.
oh,
There are two kings and two aces.
oh,
So he wins.
yes, he does.
Okay, Javier, we can talk about payment later.
Exactly, exactly. Okay, do you think this game was fair, Javier?
Yeah, I think I lost fair and square.
Okay, let me try to make it even more on your side, okay? I'm going to discard these cards and these cards, and I take the other bunch and put on top, okay?
Okay.
Those cards you mix, they are perfectly mixed, but let's make it a little bit easier for you. I'm going to put 10 cards here, and I'm going to number the position 1, 2, 3, 5, 6, 7, 8, 9. Oh, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I just 10. Okay. So we need 10 cards. I'm just discarding the rest. I can put somewhere. Oh, here. Okay. So there. Oh, this card cannot be seen properly. Okay. We have 10 cards, 1 to 5, 6 to 10. Now you are allowed to select any 5 cards.
Any 5?
Any 5. Just tell me the number. Whatever number you like. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. Give me the odd ones. Let me just 1, 3, 5, 7, and 9.
Okay. Remember, in poker, you deal for the opponent first. So you select select 5 cards. It's not for you or for him because it's a rule of poker. I don't want to change the rules of poker. You usually give your opponent the hand first, and the way you phrase "I give me" it's strange. So just select 5 cards.
5 cards.
The odd, not the odd, or the even, or what did you say?
I asked for number 1.
Okay.
Number 3.
3, okay.
Number 5.
5, okay.
Number 7.
Okay.
And number 9.
Okay, the odd numbers. This have to be for Raymond because that's the way you deal in poker. Okay, where do I put them? Here, okay. Here you can see, okay? We deal to the opponent first, and these remaining cards are for you, okay?
Okay.
So this is your losing hand, this is winning hand. Let's see what you have this time.
Okay.
You might be lucky. What's here? It is
Pair of jacks.
pair of jacks. Okay, nothing else? No? Okay. Good?
Yeah.
It looks
Okay.
good.
Let's see the winning hand. Remember to shuffle every card and you select it you wanted.
Who cares?
Oh. Okay.
Like this.
Is that a better?
Two tens and two nines. So Javier, I'm really sorry. Mathematics beats you.
And given my great good luck today, I think I should go buy a lottery ticket.
Yes. What I want to call your attention to, thank you very much, Javier. You did great. Raymond, thank you very much too for helping us to win. Imagine you have a wish. Let me go back to my sharing the screen. Imagine you have a superpower. Which superpower would you like to have? I mean, winning in poker is close to a superpower. I just showed you how you can shuffle cards, and even though you think there is no recognizable pattern, you can still tell who is going to win. And if you look at the details, you will see there is almost no information in the whole setting. But you can assure, you can say, you can tell who is going to win. So if you're going to win, that's a great advantage. So I like that superpower. But let's go back to mathematics. I just wanted to show you an example of what you can do with mathematics, and that's magic. So what I think is common to mathematics and magic is the fact that you can obtain amazing things, things that do not look natural, or things that look supernatural, through means that are accessible to everybody. Everybody can perform a magic trick. Everybody can do math. The question is, what is math? Math is everything that makes us think. If we do it correctly, we can obtain information that maybe some other people didn't. If I obtain information about something that is not known to other people, what I'm doing is magic. Let me mention some examples. How do I change here? Okay. We have lots of different areas. You have weather, you have epidemics, of course, I love epidemics. You can have gambling, cosmology, finance, in all these areas. What we want is to understand how things work. There's one key word in all this, that is describing. How do things behave? If I can understand how a bridge behaves, if it's exposed to the wind or to the cars or to the waves, then I can build a strong bridge, a long bridge, a very cheap to maintain, cheap to build. If I can produce digital music, what I need is to find out what kind of patterns I want, which pattern is pleasant to the ear. And there are some algorithms that produce those patterns. If I want to design a more efficient car, then I can use mathematics to predict more efficient, more safer cars, lots of things, even football scoring. One of my colleagues had a very serious research project on how to, what's it called in English, penalty. Remember, at the end of the game, if there was a tie, you have to shoot some penalty. Even for that, there is a very good strategy for winning. If you work in neurology, if you work in designing a roller coaster, or whatever, graphics, even the military, some people will probably dislike that, but there's a lot of mathematics in, before any confrontation, there's a lot of mathematics, a lot of modeling, what's going to happen, how much going to cost, how much they are going to lose in material stuff and people and all that. Of course, artificial intelligence is something we have in around us in recent times. Artificial intelligence sounds like something really omnipresent. Everywhere you look, there is artificial intelligence, and they tell you this is done by artificial intelligence. What they are doing is finding patterns, or even worse, they are developing software that looks for patterns. And those patterns predict and describe how things work. all that is mathematics. So if we want to work in any field, we want to recognize patterns, we want to apply them to be able to design something and to predict behavior. For instance, in pricing strategies, if you buy anything in Amazon, the prices change all the time. Did you know there is an algorithm that decides the price? It's called algorithmic pricing. And there's a lot of research in algorithmic pricing. You want to sell at some price and you want to maximize your profit. Sometimes you maximize your profit increasing prices, and sometimes the opposite way. And these algorithms were designed with the help of artificial intelligence can maximize your winning, and it's amazing. I did some analysis how many sellers in Amazon use algorithmic pricing, and most of them already use algorithmic pricing. That means the price is not decided by a person, but by a software. Of course, that software was designed by a person. But all that is mathematics. And I'm skipping a lot of examples, but I just wanted to mention how you want to find about patterns in many, many different areas. But designing patterns doesn't look like, or understanding patterns doesn't look like mathematics. Mathematics, usually people think of numbers. That's why I stress mathematics is not numbers, unless you have some patterns that are relevant. But what is relevant is the pattern, not the number. And these relationships and connections for predicting and describing phenomena. So let me go down to earth to some examples that might be closer to your everyday mathematics. Okay, it looks like mathematics should be something good because it can be used and applied everywhere. But many people ask, why is mathematics so difficult? And almost everybody agree. If a kid comes home and says, I had problems with my math exam, parents will probably agree and say, oh yes, math is difficult. I don't agree. Mathematics is not difficult. Mathematics is like, let's think of riding a bike. Is riding a bike simple or difficult? I think it's difficult if you don't want to learn it, but if you want to learn it, you forget about the difficulty. You don't remember falling down, you remember learning that and mastering the riding. Once you learn to ride, you remember what you did once you mastered the skill. You don't remember if you fall down 3 times, 5 times, or 10 times. So is mathematics really difficult? What I think is related to this saying by this guy, you might know, Confucius. I hear and forget. I see and remember. I do and I understand. What happens in mathematics, we usually hear, and we of course forget. We see and sometimes remember, if we are lucky, to the day of the exam. But if we do, then we understand, and if we understand, we don't forget. The second saying is also an interesting one. I just put it here because I think it's extremely relevant in mathematics. But okay, let me keep going. Let me go to a very simple question. How much is 35 squared? If you need more than 2 or 3 seconds, then you have a problem. It is 1225. How do you come to this number? I explain that in a moment. How much 65 squared? 2 seconds. 4225. How much is 115 squared? 13225 in 2 seconds. If you don't know how it's done, it is awful because it's impressive but useless. We don't know how to do that. We don't know how the person did it. And it is at the most impressive, but I don't get anything from it. Let's go back to something you know. Remember this formula, a squared minus b squared equal a plus b times a minus b, or I just write it in a different way. We all learned this formula. can you use this formula to solve this? Of course you can. This formula, the second one, the red one, is a wonderful example of what I mean is understanding math. If I learn the formula, I just learned something, but I'm going to forget it. And if I don't forget it, I won't use it. But let me tell you what this formula says. It's a wonderful one. It says, if you want to square any number, you can add to that number whatever you want, whatever you decide, b. I can add b, I select how much it is, b, and I take off the same amount. And then I multiply those two numbers, and then I just add the square of the number I moved. So let's take 35 square. 35, I decided to add 5. 35 plus 5 is 40. 35 minus 5 is 30. 40 times 30, forget about the 40 and 30, it's 4 times 3, it's 12. 12, and b squared is 5 times 5, it's 25. So 12, 25. It's what we had, 12, 25. Okay? Let's take the second one, 65 square. What this tells me is add 5, take 5. So it's actually 6 times 7, 42. It's and 5 square is 25. So the rule would be, if you want to square a number, just forget about the 5. What do you get? The 6. What's the next number? 7. 6 times 7, 42. And the 5 square is 25, so 42, 25. 115 square, it's 11 times 12, that's 132. If you don't know that by heart, I can show you with my hands how I don't need to learn the timetables, I can do that with my hands. 11 times 12 is 132, and 5 square is 25, so 115 square is 13,225. So this formula, the red one, I can learn it and give the answer if they ask me during the exam, or I can understand it. And understanding is just wonderful. If you want square of any number, just look at a number nearby that makes multiplications easier. For instance, 93 square. 93, I don't know the times table to 93. So 93 plus 7, it's 100. Oh, lucky me. I can multiply by 100. It's 100. 93 minus 7, it's 86. 100 times 86, it's 8,600. And 7 times 7 is 49. So 93 square is 8,649. I hope I'm not going too fast. So mathematics is not to be learned. Mathematics is to be understood. Okay? So going back to the examples, I would like to dedicate my life to cosmology or to search engines or to public key cryptography or to insurance. What do I need? Mathematics. Mathematics is wonderful. Anywhere you look for, there is mathematics. When I went to Germany to study biology, they were very happy because I was studying biology, but also mathematics. So they needed someone who understood mathematics. And I thought, that's very simple mathematics. Yes, but they need it. And later I realized they need some mathematics that is even more complicated than the ones mathematicians knew. The biology gives problems that mathematics cannot answer yet. So we have to look for new mathematics. So if you want to look for any area, sports, any world record, any Olympic record nowadays, if you want to break it, you need mathematics. Why do you go what's called the high jump? Why do you jump on your back? there is a mathematical model that tells you that you can jump higher if you jump on your back and the other way that they did it before 1968. So in sports, mathematics can help you. In magic, mathematics can help you. In music, in any area you select. Plastic surgery, erosion, cut lines, swimsuit design, fraud detection. We recently worked for the Mexican government to detect fraud detection in insurance statements. People pay taxes and they claim to have spent this and this and that. And it is extremely easy, if you know some mathematics, to detect fraud. If you invent numbers, if I ask you to throw a coin 10 times and I ask a second person to come up with the result without using coin, I can tell you who used the coin and who invented the numbers or the results. So fraud detection is really interesting. The Mexican government has a very powerful way of detecting fraud in tax result for companies and personal people. And the International Monetary Fund gave CIMAT, the institute where I work for, a prize for that algorithm for detecting fraud. Anyway, crime detection. If you hear intelligence sources tell us that there was suspicious activity or terrorism, there are huge, lots of collection of results. There are complete books on terrorism fighting. If you want to fight terrorism, mathematics is extremely helpful. Actually, it's one of the strongest weapons we have against terrorism. Mathematics. There is a lot of modeling against terrorism. There is a lot of modeling trying to predict lots of things. If you want to open a 7-Eleven anywhere, there is a mathematical model describing which location is the best, which size, which products, and which kind of customers you will have. So it is amazing the kind of things you can do with mathematics. I'm just mentioning some examples. Let me give you a final example before I go to thank you. Let me give you a final example, some irrelevant one, but I just like it. And if you want to play with me, it is a very simple one. You might not have noticed, but I hypnotize you. Are you with me? Did you notice you are hypnotized? Most people studying science, engineering are not very happy with the statement. So I'm going to prove it to you. So I'm going to give you some very simple rule, some first simple tasks you have to perform, and you won't be able to complete the task. Okay? Stretch your hands like this with your palms showing down, and you're going to turn your palms out. Your thumbs are showing to down, and your what's the name of this finger? I just the name is different language, but not in English. The pointing finger. Your pointing finger is to front. You are going to need it in a second. So your hands are like this, and you are going to pass one hand on top of the other and interlace your fingers like this, one on one. Okay, one on one, and then without moving your fingers, you are just turning, and then in one single movement, you touch your nose, do like this. Team is cheating. Team is cheating. So very simple. Let's see again. Hands like this, out, one on top of the other, interlacing your fingers, one on one, turning. Many people try, and many do not succeed. There is no not hypnotic trance or anything. It's just pure mathematics, very simple. It's not theory. What's happening is if you put your hands, there is a more natural way to cross your hands. You can do it like this or like this. I do it slowly. Just pay attention to one other option. It's irrelevant if it's left on top or right on top. It's important which pinky is first. If your pinky, the pinky on top should be the pinky on your hand, the hand that goes over the other one. And if you do that, if your pinky, the pinky should be the first one. Yes. And then the second thing you have to pay attention to is do not touch with this part of your fingers, you touch with your nails. So touch with your nails. So keep your fingers close, come close to your nose and touch with your nails. That it works. What we are doing is a knot and untying the knot. This is not a knot, this is a knot. So this or this is just, and just for fun, some extra magic thing. Try something else. Just put your hands like this. Blow on your elbow. And do like this. That's magic. Okay, let me try to summarize what I wanted to communicate in a very short period of time. Mathematics is not just number, mathematics is patterns, thinking about patterns, and everywhere we look around, there are patterns. If we want to work as a lawyer, as an accountant, as a journalist, whatever, you look for patterns. And if you understand patterns, describe patterns, and are able to predict how patterns evolve, then you will be able to do some magical things, really magical, like putting a rocket on the moon or having a GPS satellite or doing all kind of things. Let me tell you very briefly what I did with the magic game. I presented the magic trick. What I designed was a dynamical system. It's a dynamical system with several fixed points. And on all those fixed points, I know which players you want to win. So Javier was really making decisions, but they were irrelevant because the dynamical system had several attracting points, and those points attract all the winning solutions. That's just amazing. It amazes me, even though I know how it works. It's so powerful, and there are some other tricks. I have here several. I can show you if anybody asks for one more, and it's impressive. So whatever you want, even if you want to sell lollipops, sell the best lollipops in the world, you need patterns. You need to know how to produce a nice lollipop. For instance, if you eat a lollipop, at the end there is a what's it called? Piece of plastic you use to hold the lollipop has a tiny hole. There's a purpose for that tiny hole. There's a design purpose for that hole. It's not just for blowing at the end when you are, and all that involves mathematics. So mathematics is everywhere. You just mention it. I remember mentioning this to a group of students, and they said, no. If you talk about love, there is no mathematics. I'm sorry to disappoint you. If you Google mathematical model love, if you get less than 10,000 entries, I give you $10, $20, $50. Love mathematical model. It's and there are mathematicians working predicting how a relationship is going to last, and how likely it's going to be a divorce and all that. And they are extremely precise. So really any topic you can model. We have been able to model at the institute where I work. We have been modeling satellites. We have been modeling the tequila industry. We have been working for them. We work for the government, for the DNA analysis, for many things, and everything needs mathematics. So I stop here for any questions, discussion, and I might do some additional something if you ask for it. So thank you very much for your attention. If you are still awake, I'm very happy. And if I change your opinion about something in mathematics, I'm very, very happy. Thank you very much.
Oh, let's give him a round of applause. Wow. Well, thank you so much. Amazing to see how math models can describe everything around us. And now this is a time where we can take questions. So if you're in the watch party, I think it'll be easiest if you can come on down, or if you're on Zoom, you can raise your hand. I see Vincent is already jumping in to ask a question.
Thank you. And I'm trying to start my video. There we go. So I want to actually two things. The trick, one of the fascinations about the trick is how you did it. And you mentioned it was math and dynamical systems. So I was wondering if you had a short paper or a description that you could send us so that we could explore that. And you were talking my language when we're saying attractors and attracting toward a winning solution and so forth. And the other question I have is that there's some things that would be like the holy grail to model. Like if I could model and predict the stock market. Are there some things that are really not predictable in mathematics?
Wow, that's. I hope you have a next 3 hours for ideas on this. I have not written any paper because there are two different fields. That's a pity. Magicians share their knowledge, and mathematicians share their knowledge. But if I write a paper on this dynamical system, I have no idea where to publish it. Very few journals will take it. But it is a very nice thing. I might publish it somewhere. When I came up with this dynamical system, I was just playing. So for me, it's a game. I understand the mathematics, but I haven't written anything yet. I might think of it. I actually started writing a book on. I'm teaching right now mathematics and magic, and I took the opportunity to write a book. So I'm writing a book on that. That might be included. Predicting whatever is possible to predict, we can predict with mathematics. We believe that nature is not that terrible with us. If nature is predictable, the way to predict is with mathematics. That's what some of you say at the beginning, the language of the universe. So Einstein used to say, it's amazing that we can describe nature so properly, so nicely with mathematics. Nowadays, we don't think mathematics is the language of nature. Nowadays, we think mathematics is the language of the brain to understand nature. Stanislav Dehaene is one of the mathematicians that works on neurophysiology. He says the brain understands the world through mathematics. So we invent mathematics, the brain understands mathematics, the brain is designed to work with mathematics in order to understand the universe. It's not the universe there in mathematics, written in mathematics, and we just decoding it. It's the brain that trying to make sense of the universe. And I kind of tend to be on his side. I think our brain is designed to understand mathematics. Evolution made us to understand mathematics. If you throw a ball to a dog, the dog is not running to the ball. The dog is running to where the dog calculates that the ball is going to be. That is mathematics. That's a very complicated mathematics. So I think mathematics is a way of understanding the world, and it's inside our brain. And I think everything that's predictable, it's because our brain has been able to invent the language to describe it. And if we can describe it, we can predict it. I don't know if it makes sense what I just said.
No, it does. Thank you.
Thank you very much.
That was great. And I see Pearl has a question. She raised her hand in the Zoom room. Pearl, you want to ask your question?
Yeah, hi. Hi, thank you for talking so much. My question is, what drew you into mathematics compared to biology or any other field?
I didn't completely get the question. What do what? Can you repeat the question, please?
Yeah, my question is, what drew you into mathematics compared to biology or any other field you've been in?
What the comparison in which sense?
So what
Like,
attracted you to mathematics?
Oh, okay. By the way, I'm thinking. I feel attracted to any kind of knowledge, anything. If you enter my house and look for a book that's called the Book of Total Useless Information, you will find like 20 different volumes. So anything, history, biology, psychology, anything. So I wanted to study everything and I couldn't. So I had to decide on something, and someone told me physics. I try physics, I try astronomy, I try biology, I try chemistry. And I found that mathematics was in the middle of all that. And I just decided, okay, if I'm going to know very little of science, I think mathematics is a good choice. Biology is more real. It's more connected to the real world. So I decided mathematics and biology make sense. And then I discovered magic, and that's just fun. So I just play all the time with the magic. But if someone asked me to work on psychology and mathematics, I will be doing that tomorrow. And if someone asked me to do mathematics, and for instance, one of my students wanted to classify galaxies. So we started studying galaxies and classification of galaxies with models. But the tools in mathematics are so powerful that you can describe love relationship, you can flow in artery or vein, you can describe the stock market. It's just amazing. So what attracted me to mathematics was the fact that I could change to different areas, biology, chemistry, and so I wanted to know about everything. So I decided that was kind of universal language. But I'm attracted to almost any field. I couldn't mention a field that I'm not attracted to.
cool. Thank you very much.
Yeah, that's a great response. I love your passion for learning all fields. So I think we have a question from our Associate Dean, Herbert, and then another one from Jerry Philly. If you want to come down so you can ask right after him.
Buenas tardes, Dr. Barradas, y muchas gracias por tu plática.
Un placer.
Tengo una pregunta para usted. How do you engage incoming college students who have struggled during this remote learning period?
We do that every day. The first task is to convince them the evil side is not mathematics. The evil side is how you were taught. You were taught in a system that prefers mechanical thinking. I shouldn't even call it thinking. It's mechanical performing. So we are taught rules, repeat, step 1, step 2, step 3, but really understanding what is the meaning of any mathematical concept. And when you understand the mathematical concept, you see, I call it, I say it in Spanish and try to translate it. I call it the syndrome of the ojos de plato sopero. So your soup, bowl, like your soup bowl eyes. When the moment someone does this, it's like, wow, that's what it was about. I was misled. By the way, I failed one single exam in my whole life, and it was mathematics. And that made me think, because I was always thinking, what is it? Why? how does that work? And I remember my teacher, very nice person, but a very bad teacher, tell me, oh, that's the way it is. Just remember it. No, why it's like that? I don't get it. It was simultaneous equations and I couldn't get it was terrible. And I just do this and that and equal this, equal that, and this, put this on this side. It was so terrible mechanical. So what we try, we have a group of people working on this for many years. What we try is to first lose your fear to mathematics. It's not your fault, it's the way you were taught. Let's try to rediscover the passion for understanding something. If you understand something, it's like playing a video game. Every young person knows. If you want to play a video game, it is terrible. As an adult, it's terrible. And to see young people fascinated playing for 5-10 hours, it is not boring. The problem is playing, knowing the rules, how to play. So if we reteach the rules, how to play with mathematics, everybody likes playing with mathematics. If you do magic trick, if you do some nice application, if you do some really understanding, what is this for? Minus b plus minus square root of b squared. What's all that? Is it really useful? I'm always told I'm going to use it, but I never do. So give me real examples with real understanding, and that changes how people view mathematics. So it's a problem of the system. It's not a problem of the teachers. It's a problem of the system. We were taught that way, and we just keep it doing in a similar way. And it's also a problem of the system because the curriculum is very narrow, you have to cover this, even if they don't understand it, they just have to repeat it. So it is a systemic problem.
Well, I appreciate your response, and I think our students here and our faculty at MPC appreciate your response. Part of the STEM Talks funding for this comes from the HSI STEM grant, EMC Square, and the focus is to magnify resources to underrepresented students as well as the Latino community here in the peninsula. And so hearing you talk and hearing about the magic of mathematics does allow us to kind of step forward into kind of what you just said, you know, reestablish those rules of mathematics so that everyone has a fresh start into learning mathematics. And so thank you for your times. And I look forward to continuing your ojos de platos de sopera in my time here at MPC. And I definitely look forward to meeting the students that are here at the watch party. So thank you, Dr. Barradas. And the next question.
And I noticed we are nearing the end of our time, and some people do have commitments at 1 p.m. But I talked to Dr. Barradas in advance, and he said he's willing to stay on to answer more questions. So we'll get to your question, Jerry. But I did want to briefly announce that there is a survey you can fill out about today's visit. If you go to tinyurl.com/STEM-talks, I have slips of paper that you can grab one. And if you fill it out by the end of today, it's a super short one, you can be entered to win a $25 gift certificate to Ardent, which is our on-campus food provider. So you can get coffee and other beverages, food, what have you. So it's totally free. If you've already entered the survey from our last one, you can do it again because this is a totally different STEM talk. So you can increase your chances, but no more than 2, because there's only been 2. If you enter more than that, I will know. All right, so make sure to go to that and fill it out if you can. Yeah, so thank you all for coming. Let's give Dr. Barradas once more a round of applause. Awesome. And so if people need to go, I know there's a division meeting. You are allowed to go, but I would love to hear, Jerry, your question if you're still willing to ask. That's great. Come on down.
Hello. What do I do? Speak here? Yeah. Hello. When I have students complain about assignments, everything, why do I need to know this and that and then the other thing? what I'd like to do is, what I'd like to ask you is, can you critique my answer to them? And that is that I tell them, you know, mathematics is the language of the universe, and numbers are only the alphabet. Do you think that's silly?
No, I absolutely not. I don't think, I wouldn't agree 100% with your statement. I don't disagree, and I try to explain why. I think numbers is too narrow. We have to look for patterns. We have to look for more general rules. Numbers are definitely a very important way of measuring patterns, and numbers are a very good way of measuring almost anything around us. So many models and much understanding of many phenomena will go through numbers. But we confuse sometimes the fact that numbers are the object of study. And that's where I disagree. Numbers are just the tool. We want to understand how things behave. And for instance, let's try to figure something out. You want to look for terrorists in your country. What do you do using mathematics? Numbers, yes, numbers of what? What do you look for? What do you count? What do you measure? It's numbers. But what you need is something behind the numbers. What do I look for? In artificial intelligence, we do a lot of number crunching with certain information. But your thinking helps you to decide, what do you measure? What do you measure? Age, gender, nationality, passport, city, whatever. And if you put too many numbers, you don't get any answers. So you have to be selective. So there are some patterns that are related to numbers and some patterns that are not related to numbers. So the language of the universe is mathematics. That's something that I'd already commented on. I think mathematics is not the language of nature. It's the glasses we use to understand nature. Mathematics is the glasses, and we have to invent new glasses to understand nature. If someone prefers that mathematics is the language of nature, I don't have any problem with that. It's just a philosophical point of view. But I think the way of thinking is the most important thing. So if you start thinking about terrorism, about opening a 7-Eleven, where do I open 7-Eleven? Or how do I predict, let me tell you a very nice example. How do I predict the existence of the danger of heart attack? Let me tell you a surprising answer. Someone was able to predict the number of heart attacks in a big number of counties, analyzing with artificial intelligence the comments in Twitter. So you read the comments, analyze, a lot of number crunching, and then said, okay, here we will have 3, here we will have 2. And then you were able, they were able to predict. Scientific American published a paper a little bit longer, maybe a couple of years ago. That's a wonderful one because it looks like totally unrelated. Twitter comments with heart attack, like, what's the connection? And doing that, you realize that it's more than numbers. You need to start looking for something. For instance, what was the first sign for a terrorist? I was always confused with terrorists, by the way. My hair was black and my beard, and so I look like a tourist. What was the first important thing people in the airports found to suspect a terrorist? Once you hear the solution, it's obvious. But before you hear the solution, it's like, I don't know, maybe the looks, the phenotypical appearance of the person. The first red light was a person not using socks. It's like, what? Not using socks? Yes, not using socks. Someone not using socks was very suspicious. Nowadays, we added lots of elements. And once you hear the elements, it makes sense. If you are between 25 and 35, you are suspicious. But there are too many people. Okay, if you don't have a job, more suspicious. If you don't have health insurance, more suspicious. If you don't have regular income, more suspicious. And then it comes to the point where the agency visits your house, just analyzing. It's like Amazon trying to sell you something. You buy a book and then suddenly they offer you a kitchenware or something. Like, what? How do they know it's exactly what I wanted? Artificial intelligence. By the way, our students are hired by Google before they finish. Some of our students, before they finish, they're gone. The measuring of preferences, and it's measuring of hidden preferences. So preferences you might not know you have. So is that a language of nature? Maybe.
Thank you.
Thank you very much.
All right, other questions out there? Well, one that I'm still trying to understand, I know you alluded to it, but how did you stack the deck against Javier or Xavier? Like, how? Apparently you did it. You set the conditions just right. No,
I set one condition, one single condition. The stack is shuffled. They can shuffle it, and I have no idea which card is in any position. It is truly shuffled. Let me. Okay, this is shuffled. This is shuffled. I have no idea which cards in which position, and I don't care if they put it like this or like that. It works. I think it's fascinating because you think you don't know anything. I might spoil someone if I can explain it. I can explain it. Okay, if someone doesn't want to hear the explanation, just cover your ears. Let me show you the cards on one stack. And I put them in certain orders so you can recognize some patterns. You will start to recognize some patterns. Okay. I have two stacks.
okay, we can't see your stacks right now.
I know. I'm just putting them in order.
Perfect.
I'm just putting them in order, and here we go. Three nines, three tens, three jacks. The other one I just put in order. Three queens, three kings, three aces. That's it. That's it. And let me just give you a very simple explanation of what happens. You mix them, whatever you want, and you put them like this. Okay? One half on top of the other. These are 9 cards, and these are 9 cards. So if you deal 10, you are using 9 plus 1. And this one is useless for this. So whoever gets this plays with 4 cards. This is garbage.
Huh.
That's amazing. So just play with 9 cards. Give me one, take one, give me one. Whatever it comes out, I win because I play with 5, you play with 4. So the bad guy is this. And the second time, you might not have noticed it. But the odd card, the one that doesn't belong, I put on top. And I put the the odd card, I put on top. And I put the rest on top. So I have the same configuration again. 9 of a kind, 1 odd card. And analyze, just play at home, and you will see there are many outcomes. But in all the outcomes, since you play with 5 and the other person plays with 4, that is just, I mean, it's really something. I love this one. And I mean, if at the end, when everybody leaves, I can show you another one, it's even more impressive.
Oh, now you've gotten my appetite going. I was already excited just to finally understand that and to see the power of mathematics. That's so clever. So what's this other one? I gotta know.
Are you willing to lose?
Yes.
Let me write.
Mathematics, I will lose.
Let me write a piece of paper. I'm going to write something for the end.
The secret message. I feel like there needs to be some background mysterious music.
I wrote a prediction here. This is my prediction. Here. My prediction is written down. You are going to see it all the time. Now I take my small cards. I have 10 cards here. Okay? 10 cards. And I have to apologize first because you are going to lose. But the good side is you are going to make all the decisions. All the decisions are yours. They are large just because I usually perform in front of a lot of people, and I want them to see. So I could use the small ones. Actually, I have so many here that, but okay, 10 cards, okay? No, nothing else. And you're going to make all the decisions, okay? I take these 2 cards. One is for you, one is for me. You tell me which one you want. And during the game, you are allowed to pick, let's say, 2 times before your decision. Every time I put cards, you are going to decide, and I'm going to let you decide on any card, and you are allowed to pick 2 times. So which one of these 2 cards do you want, and which one do you want for me?
I want for you to have the one on your left hand and me to have the one in your watch hand.
This is mine?
Yes.
Okay, this is mine, and this is yours.
Okay.
Okay, your choice. Good. Then we have 2 cards. Let's say, which of these 2 cards do you want to keep, and which one do I discard?
Switching from that. Opposite sides.
Do you want to keep this one?
I want the watch one. Yes. And you
Okay. And the other one I discard.
Okay.
And then these 2 cards, you give me one, and I discard the other one. Which one should I keep?
I don't think I was watching his hands closely enough. But I also knew I was doomed from the start. I'll take the left hand.
No, the one's for me. You already have 2, I have 1. So the next one is for me. Which one should I keep?
The right hand.
I keep the right one,
Yes.
and I discard the other one.
Okay.
Okay. Now it's your turn. Which one do you want, and which one do you want to discard?
I want the watch hand.
Which one?
The right hand?
This one you want to keep?
You can discard the other.
I discard the other. Okay, this for me. Which one do you want to give me?
The left hand.
You give me this, and I discard the other one. Okay, next one. Let's shuffle a little bit. Let's shuffle a little bit. Okay, which one do you want on top? This, like this or like that?
Right hand on top.
Right hand on top. Okay. So give me one of these two cards. And I discard the other one. Which one should I keep?
For you,
Yes,
you can keep the right hand.
I keep the right hand and I discard the other one. Okay, which one do you want? I mean, yeah, so which one do you want? And the other one I'm going to discard.
I'll take the left hand.
Left hand. Okay, you were allowed to pick. You have not picked yet. But I'm sorry, I forgot. But last time, let me make it up to you. I'm going to show you what you already have. Okay?
Okay.
Before you select the last one. So that's what you have. I don't know if you can, if you're able.
The cards.
Oh, are you able to see what you have?
Yes. Ooh, okay.
Okay. Do you know what you have? Okay. Then I wanted to show you, to let you pick in the middle, but I forgot. So I will show you these two cards and you decide which one you want.
Mine, right? Okay. Wait, is that the right hand?
Right hand.
The
left
right
hand.
hand.
You want the right hand? Okay. So the last one is for me.
Unless that's giving him a king. True, I'm losing.
Well, let's see what you got. Wow, very powerful game. Very powerful hand. Okay. Wow. This is called Full House, I think.
Yes. Woohoo.
Wow. So you might feel good.
I feel like I could win.
Yes. Let's see what you get me.
I'm not going to. So I'm
What
nervous.
do I need? What do I need to beat your hand?
What was that?
Very few hands do that.
No. What? How?
Your decision. Your decision. And
But
remember, I wrote this piece of paper before we played. Can you read that?
yes. Thanks for your royal flush. You're welcome. I was really excited about my full house. What?
all your choices. Mathematics is powerful. It impresses me. It's just powerful.
But how?
That's exactly the point where I say, can you really distinguish between mathematics and magic? How did you do that? It's impossible. Are you talking about mathematics? Are you talking about magic? I mean, it impresses me. I have done this many times and it's like, wow, it really works. Mathematics is powerful. Magic is powerful. So that's why I love doing magic, inventing magic, modifying magic. And if you know a little bit about mathematics, it's not complex mathematics. It's very simple mathematics, or simple mathematics, not very simple. But extremely powerful. And I enjoy, I mean, also the surprise, I would say your eyes were probably like, wow, no way, that's impossible. There's no way. I made all the decisions. And by the way, I forgot to let you pick in the middle, because in the middle, I can tell you, okay, do you want to pick before deciding which one you give me and which one you select for you and for me. I can do it completely open and the output is the same. I hope I have been able to communicate a little bit of this fascination with the power of mathematics and the magic of mathematics.
Wow. Yeah, that's magic, all right. I don't understand it. I say that in physics sometimes to my students, but that in those cases, I do actually understand it. This is beyond me.
There are some patterns in mathematics that allow you to do these kind of things. And that's the nice, the funny, interesting thing. If you play with some mathematics to produce some games that people can enjoy in a different, or it's the same thing as if you apply mathematics in economy, or if you apply mathematics in whatever you do. But I would be happy to comment on any other questions anybody could have.
Yeah, sorry, I didn't mean to hog all the questions there and get to play a game. Did anyone else have any questions they wanted to ask? In Zoom, you can raise your hand, or here, you can raise your hand, literally. All right. Well, I think everyone's just wowed into amazement and astonishment. But thank you again so much for sharing this magic and this mathematics with us all. Let's once again give Dr. Barradas a round of applause.
Thank you very much. Thank you so much. I write down my email on the chat in case anybody wants to contact me.
Wonderful, thank you. And once again, if you go to the tinyurl.com/stem-talks, fill out that survey for a chance to win a $25 gift certificate. So encourage you to do that and stay tuned for more STEM Talks next year. All right, have a great weekend, everyone.